All right. It was requested that I work through this question. One of the groups in class got this and didn't have time to finish it, and it sounded like they weren't quite sure what to do anyway. So let's go ahead and see if we can figure this one out. Let's talk through how to solve a question like this. Okay, it says a wall is 12 meters long. It's timber paneled using vertical sheets of paneling of equal width. If the sheets had been 0.2 meters wider, 2 less sheets would have been required. What is the width of the timber paneling? So this isn't like, a wall like we're looking at all the walls of a room or anything. We're looking just at one wall. Okay, so I've got my one wall here. Okay, and I have 12 meters there. And then I have these panels. Okay, panel. And I don't know how many are in between. But then I have panels over at the end as well. Okay, of equal width. So I assume that's going to be important. So there's the width. All right. So if the sheets had been 0.2 meters wider, 2 less sheets would have been required. All right. So let's define our variables. We've got W, which is the width of a panel. And then I'm going to do P, which is going to be the number of panels. Okay, because I don't know how many, and there's something about the number of panels. 2 less sheets would have been required, so the number of panels there. Okay, so let's see if we can deal with what we have. First, we've got 12 meters. Okay, and 12 meters is the width of a panel. So I actually don't need the meters. So it's the width of a panel times the number of panels, right? If we know how many panels there are, then given that it's 12 meters, we can find the width. Okay, so we've got 12 equals PW. Now, it's giving us another situation here. It's saying, okay, well, if the width was 0.2 meters wider, so if we take that original width and add 0.2, right? So now my width is 0.2 meters longer, then the number of panels that I need will be 2 less. So however many panels I needed before, I now need 2 less of them. However, that distance is still going to be 12 meters. All right, so now I have 2 equations with 2 variables. Now the temptation is just to set them equal to each other, but that accomplishes nothing. Why does it accomplish nothing? Well, if you go W times P equals W plus 0.2 times P minus 2, what have you accomplished other than creating another equation with 2 variables? Absolutely nothing. When you substitute, the whole point is to substitute for one of the variables. Get rid of one of the variables. So we're going to get rid of that. All right, and we're going to try substituting for one of the variables, and so I need to solve for either W or P. Now, I actually want in the end to solve for W, so I kind of want to keep W there. So let's solve for P. So I'm going to divide both sides by W, meaning that 12 divided by the width tells us how many panels there are. We're now going to take this and put it in for P. All right, so this equation right here is now going to be rewritten as 12 equals W plus 0.2 times 12 over W minus 2. All right, now from that point, we now want to be able to solve this. But, having a W on the bottom of the fraction like that, that is really, really annoying to me. I would really like to get rid of that. You can get rid of it now, you can get rid of it later, it doesn't really matter. Let's go ahead and maybe just, I don't really like it, let's get rid of it. So it's on the bottom, so what I'm going to do is multiply both sides by W, multiply this side by W, multiply that side by W. Now this W, because it's being multiplied by this here, is going to distribute to both of those, right? And so now I'm going to have 12W equals W plus 0.2. It doesn't have to distribute to both of these. And don't, just like if you had 3 times 5 times 4, you could multiply 3 times 5, which is 15, and then multiply it by 4 to get 60. Or you could do 4 times 5, which is 20, and then multiply it by 3 to get 60. That 4 doesn't go to both the 5 and the 3. That 3 doesn't go to the 5 and the 4. It's just do one thing at a time. So I'm going to multiply by W. W times 12 over W will just give me 12. And then minus 2W. From here, you can FOIL this out. And if you FOR it out, you'll have 12W equals, what is that incessant beeping? It's driving me crazy. Anyway, 12W, W times 12, W times negative 2W, which will be minus 2W squared. Then 0.2 times 12, which will be plus 2.4. And then 0.2 times negative 2W is minus 0.4W. And so from there, you can simplify. We'll move the 12W to the other side, or you can move all these things to the other side. It just depends. You know, I like the 2W squared to be positive, but it might be easier just to go minus 12W right now, minus 12W. Those will cancel out, leaving me with 0 equals negative 2W squared minus 0.4W plus 2.4. At this point, you've got a couple of options. You can do whatever you want. If you've got your calculator, obviously you can just plug this into the calculator and find the intersections. The other possibility is you could do quadratic formula. You can complete the square. If you're going to do one of those, maybe you want to get rid of the decimals, so you can multiply everything by 5 or something to get rid of the decimals. That'll make things a little bit easier to factor or deal with in the quadratic formula. But you can solve this however you want. I'm going to choose to do it on my calculator because I can. And so I'm going to go into my calculator. I'm going to go y equals, and I'm going to go negative 2x squared minus 0.4w plus 2.4. And so then I'm going to graph it. There you go. You should then be able to calculate the intersections. There are 2 of them, but only one of them matters, which is this one over on the right. Oops, not intersect. Brilliant me. I'm looking for the 0. So left bound, right bound, guess, and I get that W equals 1. That's what it said on the calculator right there. And I know it's that one, not the other one, because I can't have a negative width. Now, why am I getting another one? Well, because I multiplied by the variable here, which meant that I'm creating a new answer. That negative 1 came from when I multiplied by W. So the width is 1 meter. If it was 0.2 meters wider, then you would need 2 less sheets. Check that out. Well, 12 meters at 1 meter each would be 12 sheets, right? If it was 1.2 meters over 12 meters, then you only need 10 sheets. Checks out. Sweet! So there's that problem. Hopefully that made sense. If not, feel free to ask. Ciao.